Yes, hello. How are you today, grade 12s? Yes, I'm sure and I know you did pass mathematics paper 2. So today I want us to do physics paper 1, that is 2023, to prepare you for the coming paper on Friday, which is November 2024. Okay, so we are doing 2023 physics paper 1. Now please, this video is meant for you to understand whatever they wanted you to do in November 2023 without crane work. Okay, please understand, don't crane. Let us start now. Yeah, we are starting right now. This is November 2023 physics paper 1. All right, question 1.1. It says that a constant net force is applied to a block. Which one of the following statements is correct? Note the points here. A constant net force is applied to a block. Which one of the following statements is correct? Now, they say the block will move with a constant velocity, constant acceleration, constantly increasing acceleration, and a constantly decreasing acceleration. Okay, so now we know because the block is in motion, we're going to enjoy the second law of motion as well. So we know that it says that F net equals to what? F net equals to MA. F net equals to MA. But we know that because they said it is a constant force, okay, mean that what we have here is our constant net force as well. So we give it a number. Let's give it 100 in this case, okay. If the net force is 100, now the mass is not changing. Let's say that the mass is 20, okay, and then acceleration. So if I divide by 20, and divide by 20 here, so what's our acceleration? We see here it is 5. 5 equals to A. Now I'm going to ask you, this 5 is the acceleration. Now is 5 increasing? No, which means this is not correct. Okay, now I'm going to ask you, is this 5 decreasing? No, so this is not correct. Okay, now is this 5 velocity? No, it's acceleration, so this is not velocity. So is 5 a constant? Yes, so the answer is with a constant acceleration. Okay, here we continue. Next question 1.2. A crate of mass m is stationary on a plane inclined at an angle theta with the horizontal. Which one of the following statements regarding the magnitude of the frictional force acting on the crate is correct? I repeat, a crate of mass m is stationary, so it's not moving. Okay, on a plane inclined at an angle theta with the horizontal. Which one of the following statements regarding the magnitude of the frictional force acting on the crate is correct? Now, because it's going down, frictional force is pulling up. Okay, are we together? All right, and then, but they said stationary. Now, you see this crate has got a mass, okay? Now, the mass m, because of this mass m, it has what we call as the weight, okay? Now, the weight, which is our Fg, it acts vertically downwards. That's our Fg here. Now, this Fg has got two components. One component is called Fg perpendicular, which is always exactly opposite the normal force. Okay, so in this case, this is the normal force, that is F normal. Okay, this is Fg perpendicular. Why? Because it is perpendicular to the surface. That's our Fg perpendicular. But however, most importantly, so another component is parallel. This is Fg parallel. Now this component is the component responsible for taking the block down the slope. That's our Fg parallel. So because the block is stationary, it means the frictional force, in this case which is static, is equal to the Fg parallel. That's the component of gravity that acts parallel to the plane. Let's check the answers now. So here they say number one, they say that the magnitude of the frictional force acting on the crate is part A, is equal to the component of the weight of the crate, which is parallel to the plane. What are you waiting for? That's our answer. We don't need anything else because we saw it is stationary. And this FG parasol, because it's not moving up or down, they must be equal. They must be equal. All right, next question here. They say that that's 1.3. They say that a ball is projected vertically upwards from the top of edge of the building. Points P, Q, R, and S represent different positions during the motion of the ball, as shown in the diagram below. So this point P, point Q, point R, and S down here on the ground. They say ignore the effects of air friction. Okay, between which 2 points will the ball undergo the greatest change in kinetic energy? I repeat, between which 2 points will the ball undergo the greatest change in kinetic energy? So we're looking for the change of kinetic energy, but must be the greatest. So we choose 2 points. Okay, like is it from P to Q, is it from Q to R, from R to S, or what? Okay, so now looking for the change, we're going to set our change in EK. Okay, change in EK equals to EK final. Okay, EK final minus what? Minus EK initial. So in this case, if we talk about from point P to point Q, now this ball has got initial velocity. Let us give it 10. Okay, it said V initial is 10. Okay, if V initial is 10 meters per second, now when it goes to maximum height Q, guys, you know velocity is what? Velocity is 0 here. So our change in EK for PQ, okay, our change in EK for PQ is going to be, this is the final at Q minus initial at what? At P. Let us give our mass, our ball a mass of 2 kg. Okay, so the EK final is going to be a half, okay, times the 2, then times velocity final, which is going to be 0 at maximum height. Okay, 0 squared, then minus EK initial, which is a half, okay, times 2 times 10 squared. So you're going to get here what? 0. Now the 2 cancel here, which gives us 100. So there we have 100 joules, okay, negative, okay. Now look, consider now from Q to R. Now from Q to R, from Q it is from 0 velocity. What about R? It's going to be 10 as well, because same height as P. So our change from QR, the EK from Q to R changed, is going to be a half times M at Q, mv at r squared minus 0. So basically it's going to be this 100 minus 0. 100 minus 0, which gives us what? Which gives us positive 100. So this time it is 100. Why do we say 100? Because at r the velocity is 10, and we saw with 10 is 100. So from q it was 0. So which answer do you get here? We get 100, okay, 100 joules. Now from R to S, let's say at S, it hits the ground with a bigger velocity, which is 20, okay. Now from R to S, okay, you're going to have a half times 2 times velocity at S, which we are assuming is 20, that's times 20 squared, okay. Then minus velocity at R, which is, we said 100 in the final answer there for the kinetic energy. So what is 20 squared, guys? 20 squared is 400, okay. Then minus 100, what do you get here? We get 300, okay, joules. Now also consider from Q to S. Now from Q to S, our velocity there is 0. What about here? It is 20, okay. So the change in kinetic energy from Q to S is going to be our change in EK, okay, equals to a half, okay, times 2. Velocity at S is 20, that's 20 squared. What about at Q, velocity is 0, which gives us kinetic energy. So what is 20 squared? It gives us 400, okay. Now if you look at these answers here, which one is greatest? So we have the 400, we have the 300, okay. Then we have the positive 100 and the negative 100 here. So they said Between which 2 points will the ball undergo the greatest change in kinetic energy? So because this is the biggest of these ones here, it means our answer is going to be between point Q and the point S. So do we have it here? By the way, this is PS, PR, RS, and the Q. So the answer is D. I hope it will make sense to you. The answer is D here. Next question on the Q. What do we have? Let's find out. Okay. Now 1.4. 1.4. A ball is dropped, meaning V initial is 0 because the ball is dropped. Okay. From a height h and strikes the floor with the momentum p. So at the floor here, the momentum is what? Is p. But how do you find that momentum p? I'm gonna call it p1. Eh? It's mass times velocity. Okay. Then they say the ball is then dropped from a height h. Also here v initial is 0. Okay. V initial still is 0. And then from a height half h. So it's our change in y. Now they say ignore air friction. They say which one of the following represents the momentum of the ball when it strikes the floor after being dropped from the height a half h. So we have the first momentum here, mv, which is the p. Okay, that's what they say. This momentum is p here, and then they say what's the momentum at this point now from a half h. Okay, so in this particular case, now because we have our change in y, which is the h, we have the v initial. We talk about momentum. We don't talk about change in time. So because I don't talk about change in time, I'm not gonna use the equation with the change in time. I'm interested in momentum. So momentum, okay, like you see here is mass times velocity. Eh? Mass times velocity. So my task is to find this velocity here from equations of motion. Okay, I'm gonna say v squared, v final squared, okay, equals to v initial squared, okay, then plus 2 times acceleration, which is d, then times the height h. Okay, so because it was from 0 initially, our v final is going to be the square root of what? Of 2gh. Okay, now this is from the height h. Now from the height half h, okay, I'm going to say this is v2. Okay, that is v2 here. That's v. Now from here, by the way, what's my momentum here? Remember, momentum is mass times, but it's going to be momentum. That's the initial one. Equals to the mass, okay, then times dc velocity, which is 2g height h. So that's equation 1. Okay, now equation 2, if I look at now this half h from here, my final velocity, okay, is going to be square root, okay, of what? Of 2g mara the height is a half h. It's going to be h over 2, okay. So now in mathematics, this one, I can write it as square root of 2gh divided by square root of 2. Are we together? So now you guys, you can see in this case that my new momentum that I'm looking for now from the height a half h is going to be momentum p2. Okay, the mass is the same. What about velocity? Open brackets here. You're going to have what? 2gh divided by what? By root 2. Okay, but you can see that this square root, okay, this one here on top, if you take it properly, is the same as what we have here. Okay, so in other words, my momentum at a half h is gonna be the same as p but divided by root 2. So our answer is going to be p divided by root 2. So it becomes what? Answer becomes b. I hope we are together. Let us continue. Next question here. Next question, where are you? It's here. Okay, that was 1 point. 1 point what? Next it must be 1.7, right? Let me check. This was This was 1.2. Okay, 1.4. What is 1.5? (1.5). A box moves in a horizontal surface. The diagram below shows all the forces acting on the box, okay? And then they say here, which one of the following combinations of forces do work on the box? I repeat, they say that a box moves on a horizontal surface. The diagram below shows all the forces acting on the box, okay? They say which one of the following combinations of forces do work on the box. So guys, what is work? What is work? What is work? So work, we know that it's defined by this equation, okay? So work equals the force, okay, multiplied by the displacement altogether times what? Direction of the force, which is cos of theta. So now for us to do work, if theta is 90, it's going to give us 0. Are we together? So in other words, if the force is perpendicular to the displacement, we are going to get z cos of 90, which is 0. So if you check here, guys, if I draw now, because it is moving horizontal, it means that in this particular case, I can say that it's moving in any either to the left or to the right. Okay. So if I may draw my horizontal like this, indicating the what? The displacement, okay, or direction of this block. If I consider my force S, what's my theta here? With the force S, my theta is 0. So because of 0, what is cos of 0? Cos of 0 is 1. So being 1 times the F times displacement, I'll get positive work done. So mean that the force S does work. Okay. Now look at my force, which is P. Now my force P, as you can see that P is perpendicular to the displacement, okay? This 90 degrees, it means cos of 90 is 0. 0 times delta x times f gives me 0. So mean that my force P doesn't do any work because of the theta being a 90. Now if I look at my R, my force R, it is also what? Also perpendicular. Check it, guys. This 90 degrees here. So being 90, again, the cos of 90 is going to be what? Is going to be 0. 0 times the force and displacement, I'm going to get 0 as well. So my R doesn't do any work. Look at Q. Now Q, it's in this direction. Now, which means our theta, like this. Now, our theta could be maybe 60 degrees. So, if I talk about cos of 60, which is a half times delta x times force, I get positive work done. I get work done, okay, which is not 0. So, my force Q does work. So, what do we have here? The solution of the following combinations of forces do work. They do work. So, I have got S and Q. So, the answer is B. Hope we are together, guys. Next question here. 1.6. They say that a train moving at a constant velocity towards a stationary listener emits sound waves of constant velocity frequency. I repeat, a train moving at a constant velocity towards a stationary listener emits sound waves of constant frequency. Which one of the following statements about the sound waves observed by the listener is correct? Which one of the following statements about the sound waves? That's our lambda, okay? Observed by the listener is correct, okay? Now let us talk about the theory. If the train is moving at a constant velocity towards the listener who is stationary, we expect and we know the noise is going to increase. Because the noise of the sound is increasing, it means the frequency is going to increase. Are we together? F listener is going to increase than F source, okay? Now the frequency and wavelength, they are inversely proportional. Are we together? Are we together? The frequency and the what? And the wavelength, they are what? They're inversely proportional. So in this particular case, now as the train approaches the listener, the frequency is going to be higher. So if the frequency is higher, what about wavelength? It becomes lower. Let us check the answers now. So they said that the observed frequency is higher than the emitted frequency. The question said that which one of the following statements about the sound waves, not wavelengths, about the sound waves observed by the listener is correct? So they say the frequency of the frequency is higher than that emitted by the frequency, than the emitted, which means that F listener, okay, is higher than F source. And what are talking about? That must be the answer now. Check other options, guys. They're saying the wavelength is longer than emitted wavelength. Now, this one is not correct because wavelength we see here, it must be what? Must be smaller to get higher frequency. This is not right, okay? Look at C. Frequency is lower. That is, of course, not right because it's higher. Wavelength is equals to the emitted wavelength. That's not correct because here we have relative motion, okay? Next question, that is 1.7. They say here that refer to the diagram below. Q and R are small spheres surrounded by the light insulated strings here. I repeat, Q and R, they are small spheres which are suspended by light insulated strings, okay? When a negatively charged rod is brought close to sphere Q is repelled. When the negatively charged rod is brought close to sphere R is attracted. Okay, so they say here that which one of the combinations below can be possible for the nature of the charges on the spheres Q and R. Now we know from the electrostatics that if this rod is negative and repels Q, it means our Q must be negative. Why? Because a negative repels a negative. Okay, we come here now. Now this rod is negative. Our sphere R, we don't know yet, but it is being attracted. What do we know about the negative? Now the negative always attracts what? Attracts a positive. Are we together? So our answer, it can be, I repeat, it can be, or is supposed to be a Q being negative and the R being positive. Do we have it? This is Q, this is R. Q, negative, positive, negative, 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 neutral. So we don't have negative, positive. Now the other alternative by polarization to the negative to attract this sphere R could be what? Could be neutral. Could be neutral. So the answer becomes is negative and then the neutral. So the answer here is D. The answer is D. I repeat, repulsion, we must have negative repelling negative, but for attraction, the negative can attract a neutral sphere by polarization, or can attract a positively charged sphere. So the answer is D, negative and a neutral. Next on the Q, let's check it out. They said that 4 voltmeters V1, V2, V3, and V4 are connected in a circuit as shown in the diagram below. So this is V1, this is V4, this is V2, this is V3. They say here that which voltmeters will have the same reading as voltmeter V1 when the switch is open. Now V1 is supposed to read two things. V1 can read EMF, all of V1 can read what we call as the terminal voltage. Now, if the current is flowing through the circuit, this V1 reads V external, which is also called terminal voltage. However, if no current is passing through this external circuit, then V1 reads EMF. Okay. Now, in this particular case, they said that Which voltmeters will have the same reading as voltmeter V1 when the switch is open? Did we hear that? When the switch is open. Now, when the switch is open, we don't have any magic here, which means no current is passing here because the switch is open. So if no current is passing here, it means zero current here altogether. So if this is zero current, then voltmeter V2 is going to be 0 times what? Resistance, which gives us 0. Okay. Likewise, this voltmeter V4, this is an ammeter. Now, an ammeter has got negligible resistance. So also V4 will be also 0. Okay. Now, this V3 which you see here, V3 is opposite to this V1 and it's going to read V1, which they both in this case with EMF. So V3 and V1 will have the same reading. Okay. So the answer is going to have supposed to be V3 only. As you saw these others, they are going to have got 0. So the answer here is going to be B. Okay. Hope we are still together. Next question here, that is question 1.9. They say here that a split ring commutator connects the coil of a generator to an external circuit. Oh yes, we know that a split ring commutator connects the coil of the generator to an external circuit. Okay, and then they say which one of the combinations below is correct for the magnitude and direction of the induced current in the external circuit. So now you know that the induced current depends on the position of our coil. Okay, if our coil is horizontal, okay, if our coil is horizontal like this, we expect maximum induced current. Okay, and if our coil is vertical, okay, like this, if it is vertical, what do we expect? We expect minimum current. Okay, so in other words, the induced current changes from maximum horizontal, minimum vertical, maximum minimum, which means that here the induced current it changes, but the presence of the split rings commutator, it is going to convert the changing current to a constant induced current to the external circuit. So in other words, it's going to convert it to something which is constant current. Are we together? So the answer is going to be C. Hope we are together. 1,10. They say here that light of a suitable frequency is shown on a metal surface and electrons are ejected from the metal surface. I repeat, light of a suitable frequency is shown on the surface of the metal and electrons are ejected from the metal. Which one of the following is equal to the ratio of the wake function to the threshold frequency of the metal? So alright, so which one is the ratio? We need the ratio. Ratio means we are dividing, okay? Of the wake function, that's W naught, okay? To the what? Wake function to the threshold frequency, that's our F naught, okay? So what is here? Now, we know that in this case, the wake function is given by Planck's constant multiplied by what? By threshold frequency. So divided by threshold frequency, divided by threshold frequency. So if you check this out, our H indeed is the ratio of the work function to the threshold frequency. So this case the answer is A. Alright, let us go to question 2. Hope we are still together. Alright, question 2, November 2023. Two blocks A of mass 4 kg and B of mass 9 kg, they are connected by a light inextensible string. The blocks are held at a rest on a plane which is inclined at an angle of 35 degrees with the horizontal. A constant force F acting parallel to the plane is applied to the block B as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. Okay, I repeat, two blocks A and B of mass 4 kg and B of mass 9 kg, they are connected by a light inextensible string. Now guys, whenever they say inextensible, mean that the tension is the same. So if I talk about the block of mass 4 kg, the tension is pulling up like this. Tension is facing up, okay? Then if I talk about the block of 9 kg, the tension is acting downwards then, okay? So that's why we call it what? Inextensible. It is uniform, okay? Does not change. Okay, now they say here that the blocks are held at rest on a plane which is inclined at an angle of what? Of 35 degrees with the horizontal. Okay, that's not a problem. There's a constant force F acting parallel to the plane as applied to block B. You can see that here as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. Guys, the 2 meters per second squared is acceleration. Okay. If they say constant velocity, it means zero acceleration. In that case, our F net will be equal to ma, which is 0. So now they say 2.1 state Newton's second law of motion in words. How do we state it, guys? When a net force acts on the body will accelerate in the direction of the force, with acceleration directly proportional to the force and inversely proportional to the mass of the body. Next question. The kinetic frictional forces acting on blocks A and B, they are 5,88 and 13,23 newtons respectively. Meaning for block A, it is what? It is the 5,88, and for block B, it is what? It is the 13,23. That's what respectively means. They say that draw a labeled Fibor diagram showing all the forces acting on block A. Now guys, if you're doing your Fibor diagram, I advise you to draw your surface first. You see my surface like this. So what I do here like this now. So it's my question 2.2. What I do, I first draw my what? My surface. Okay, that's our surface, guys. There, I think you can see that. Now our surface, as you can see, it's at an angle. Then you put the free body. You put what? The free body. A free body is a big dot like this. You can see it here. Now from there, ask yourself, this body has got a mass, so because of that, it must have weight. Now the weight is acting vertically downwards, okay? So it's our weight Fg, which acts vertically downwards, okay? So that's our weight here. We use W, or you can use Fg, and we together. After putting the Fg, now being the mass on the surface exerts a normal force, okay? So normal in physics is not normal in life sciences. In physics, the normal we mean it is perpendicular. That's why it's approximately what? Perpendicular like this, as you can see, okay? And then what else do we have? Now talking about block A, okay? Now this block A is pulled by the tension, so we're going to have the tension here, which is pulling up the slope. So we are pulling our free body by tension. So this tension is going to be parallel to the what? Parallel to the surface, to the slope. So that's how it goes, okay? Hope you can see that. That is our tension force, okay? Our tension force there. And then because there's frictional force, because the block is moving up, the friction is going to be facing down, okay? Facing down, but friction must be smaller or shorter than the other arrow. Why? Because the thing is moving up, so the upward component must be larger. So now when you are done, you can now feel free to remove the what? The surface like this, okay? Move the surface now. Okay, so now from there we can use the labels which we know, okay? So we know that for normal force we use F normal, that is capital F with N, okay? This is the tension, okay? This is our Fg, this is frictional force. Because it is moving, we call it what? Kinetic frictional force. So there you go with your 4 marks with and the 4 arrows coming from the dot to show your free body diagram. Now they say I'm 2.3. Calculate the magnitude of the tension in the string. Okay. Now the tension in the string is what we are looking for. By the way, this figure diagram, someone else can draw it like this. Okay, can also draw it like this. In this particular case, we can have the one which is the normal force being opposite to the what? The FG perpendicular. Okay, and this case, these are F normal. Okay, these are FG perpendicular. Then in the middle, we put what? The free body. We put the what? The free body. Now we have this force which is pulling upward. That's a tension force. As you can see, it is like this. Okay, that's our tension there. That's our tension there. And then now this tension force is being opposed by two forces. From this Fg, we have the Fg parallel together with the frictional force. So here I'm going to have my frictional force. Okay, frictional force here all together, and then also I'm gonna have what? My FG parallel. Okay, FG parallel like this. So this is FG parallel here, FG parallel, and this is FK. So this is the FG parallel. Okay, this is FG perpendicular. Okay, this is F normal, the normal force, and this is frictional force because it's moving. It's gonna be called FK. Now the question says calculate the tension force. Okay, let's check what we have now. What do we know? We have the mass of the block A. The tension is here. Then we have the angle at 35. The mass is 4 kg. And acceleration is 2 meters per second squared. Hope we are together, guys. Let's see what to do now. So because it is moving, what do we say? Because it is moving, we are going to say that our F net, okay, our F net equals to what? Equals to MA. F net equals to MA. F net equals to MA. So now F net is the sum of the forces in the line of action. So the tension force is being opposed by what? Opposed by frictional force, which is Fk. Also opposed by what? By Fg parallel. Okay. Then should give us what? Should give us the mass times acceleration. Okay. So here we go. Looking for the tension T. Now the Fk was given to us. Let's check it now. Okay, I'm gonna put shortly. Looking for Fk here, they gave it to us. How do you find Fg parallel? We use mg sign, okay? That's mass of A, okay? G sine 35, right? Sine 35. Then equals to M, that's gonna be the mass of A times the given acceleration. So we're now substituting, we're looking for this tension T. So which Fk do we have? Check the question where they say respectively. Our Fk, it is 5,88, okay? 5,88. What about the mass? His mass is 4 kg. So we say here it is 5,88. So we say that here our tension T, then minus what? Minus the frictional force, which is 5,88, okay? 5,88. The mass is 4. What about gravity? 9,8, okay? What about our theta? Sine 35 here, okay? And then equals to ma, the mass is 4, acceleration is 2. So in this case, our t is going to be what finally? Anybody with a calculator, you can help us here. You're going to say 8 plus 5,88 plus, open bracket, 4 times 9,8, then sine what? Sine 35, okay? It gives us here 36,36 newtons. So take your answers there. Do you get 36,36? If the answer is yes, then we are both correct. Okay. Next question here. What must we calculate? What are these telling us to do? They say that now get what? The force F. Now to get our force F, now the force F, as you can see, it is pulling block B opposed by the tension together with the FG parallel for block B. I repeat, the force F is going upslope opposed by tension and opposed by FG parallel and opposed by frictional force equals to MA. So in other words, to get our force F, we are going to say that our force F, okay, our force, after saying F net equals to MA, F net equals to MA, okay, like we said, F net means the forces, the sum of the forces in the line of action. The forces pointing up, they're going to be positive, down in negative. So, considering the 9 kg block, which forces are pointing up, guys? We have the force F. So we're going to say our force F, okay? What about pointing down? We say minus now. Minus tension force, okay? Minus frictional force, okay? This is now for block B. Then minus FG parallel, okay? Equals to MA, but the mass must be what? Mass of B times A, okay? So now we're looking for this force F. We're going to say F here. The tension we got 36,36, okay? 36. What about frictional force here? They gave us 13, what? This one here. 13,23, so minus 13,23, okay? And then what about FG parallel? It's going to be MG sine, but the mass is 9,8, okay? Rather 9. What about G? 9,8. Then sine what? Sine 35, okay? Sine 35 should be equal to MA. The mass is 9. What about our A? It is 2, okay? So now, can I have the final answer for the force F? So our force F equals to what? Anybody with a calculator? We are going to say 9 times 2, which is 18, then plus 36,36, okay, and then plus the 13,23, okay, then plus, open brackets, 9 times 9,8, then times sine 35, okay. What do we get here? We get 118,18. So our force F is 118, okay, 180 newtons. All right. Hope we are together. Let's continue. They say the angle that the plane makes with the horizontal is now decreased. How will this change the kinetic frictional force acting on block A? Choose from increases, decreases, or remains the same. Explain your answer to show that you did not guess, okay? They said the angle that the plane makes with the horizontal is now decreased. How will this change the kinetic frictional force acting on block A? Choose from increase, decrease, or remains the same. Okay, now guys, here the answer is going to be what? The answer is going to be decrease. Okay, I mean it's going to be increase, sorry, it's going to be increase here. Now they say if you did not guess, explain how. Now you know what, the frictional force Fk is equal to the coefficient times F normal, okay? Mara, for the inclined plane, our F normal is the same as FG perpendicular, okay? The same as what? FG perpendicular. Now, when the angle is decreased, our FG perpendicular is going to increase, okay? I repeat, when the angle is decreased, okay, our FG perpendicular is going to be what? It's going to increase. So because of increasing F perpendicular, and then the coefficient is constant, okay, so we have a big number for what? For FG perpendicular. So because of this big number, we can see that the frictional force must increase. So that's why it increases. So we say it increases. Why? Because decreasing the angle increases FG perpendicular, and that is when multiplied by coefficient gives us a larger frictional force. Okay, next question here. That is question 3. They say here that on question 3, what are they saying? They say here, a ball of mass 0.5 kg is thrown vertically upwards from the top edge of the building, which is 15.3 meters high. The ball reaches maximum height of 5.89 meters above the top of the building. The ball strikes the ground and bounces vertically upwards, reaching a maximum height at point P as shown in the diagram below. You can see this. Okay. Then what happens next? They say ignore air friction. Define the term free fall. So what is free fall? Now free fall is the motion of a body which is only influenced by the force of gravity. I repeat, free fall is the motion of a body which is influenced by only the force of gravity. What about a projectile? A projectile is an object given an initial velocity in motion which is only influenced by what? By the force of gravity as well. Okay. Now here they say I'm using only equations of motion. Calculate the speed at which the ball was projected upwards. Okay. So looking for the V initial. Looking for the what? For the V initial. So for that case, let us choose. Now I'm going to choose down as positive. Okay, I choose what? Down as positive. Okay, that is 3.2. So 3.2 here. If I choose down as positive, okay, 3.2, choose downward motion as what? I wanted to say upward, sorry. Choose upward motion as positive. Okay, choose upward motion as what? As positive. Now, the moment you choose upward motion as positive, please listen carefully. It means that our gravity now is negative 9.8. Okay. Then we're looking for the V initial. Okay. And then we know that at maximum height, velocity is 0. Okay. Velocity there is 0. So mean that our V final is what? V final is 0. Now, because we chose up as upwards, our change in y, okay, is going to be also positive what? From starting point, it's going to be positive 5.89. It is positive 5.89, positive 5.89. So now if you look at my variables here, I don't talk about change in time, meaning that all the equations containing change in time, I cannot use them. Why? I'm going to get stuck. So I rather use what? I rather use V final squared, okay, equals to V initial squared plus 2a change in y, okay. So V final, we saw it is 0. We're going to say 0 here. What about, we're looking for the V initial, that's Vi squared, okay, plus 2a. What's our a? Negative 9.8. Think you see it here. What about our change in y? It is positive 5.89. Positive 5.89. Okay. So what's our final answer here going to be? Anybody with a calculator? What's our V initial gonna be after taking the square root? Let's check it out. We are gonna say square root 2 multiplied by 9.8, okay, multiplied by 5.89. So what do we get? It gives us here 10.74. So I get here 10.74. That's my V initial, 10.74 meters per second. Now, if the question is asking for the velocity, we tell them upwards. If they say speed, don't tell them direction. Why? Speed is a scalar quantity. Because we talked about speed here, you can see, we only say it is what? It is 10.74 meters per second. Okay, next question here. What do they want now? Let's check. They said that after the collision with the ground, the ball leaves the ground with a speed of 11.92 meters per second. Okay. this velocity of bouncing from the ground, ne? So this is velocity of what? Bouncing from the ground, which VB. Now remember we chose up as positive, ne? This one is also going up, so it's gonna be positive, ne? Positive 11, comma what? Comma 92 in our context, okay? There's a calculated amount of kinetic energy lost by the ball during the collision with the ground. Now, when the ball hits the ground, there is velocity here, ne? The velocity at this point here, okay? Which I'm gonna call V final for now, okay? And then that V final is gonna be the velocity we are hitting the ground. Then as the ball leaves the ground, we are going to lose some velocity. We are going to lose some energy. That's why our velocity now is what? It is 11,92. Let us first find this V final here, and then we proceed from there. Because we know that our energy lost, okay, is change in EK. Is change in what? Change in EK. Change in EK given by what? By EK final, okay? EK final minus what? Minus EK initial. Okay, so here we go. Let's first find our final velocity here to be safe. If you look at what we have here, now because I want to use from the starting point now, my change in Y is going to be negative 15,3. Okay, now I know my V initial, which is this one here, the 10,74, and I'm looking for the velocity here, and I don't talk about change in time, so I rather use again the V final squared. I'm going to say now V final squared, okay, equals to V initial squared plus 2A change in Y. So now my V final is what I'm looking for here. So V final squared, okay. Now V initial from here, from the starting with the balcony, is what I'm starting with, which is the 10, what? 10,74. And because we chose up as positive, it must be made positive. That's going to be 10,74 squared, okay. And then plus 2A, plus 2A. Now that A is the 9,8, ne? But because we chose up positive, it's going to be now made negative 9,8. What about our change in Y? Because we are going up, so going to be now negative 15,3. Negative 15,3, okay? All right, so looking for the B final here. After taking square root, what do you get, guys? Let's check it out here. Check it out here. What do we use now? What do we use now? In this case, calculators, please help me out. What's your answer there? What's your answer there? What is your answer here? Square root. I have first of all 10,74 squared, and then plus open bracket 2 times 9,8 times 15,3, okay, which gives me here 20,38. So my B final is 20,38 here. I don't know what you get that side, but here I get 20, what? 20,38. Okay. Now that velocity is velocity for hitting the ground. But remember, we're looking for velocity for changing the kinetic energy, the kinetic energy lost, okay? They gave us velocity for, now this V final for hitting the ground becomes our V initial as we hit the ground, okay? It's now what? It is 20,38. But because we chose up as positive, it's going to be made negative. Now the V for leaving the ground, which we call the V bounce, is positive what? It is positive, let's check it again, 11,92. So this is positive 11,92, 11,92. Then we need our change in the EK here. So how do we find the change in the EK to get our energy lost? Change in the EK, okay, change in the EK equals to EK final. That's going to be a half times the mass. But the mass, we know it is what, by the way? the mass for this ball. They said 0,5. Let's check it again to confirm. Yeah, 0,5 kg. So I'm gonna say a half times 0,5, okay, times 0,5 here, open brackets. Now v final squared, which is velocity for the bouncing, that is 11,92 squared, okay, minus v initial squared, which is what? Which is 20, but negative 20,38, okay. Don't forget must be squared, okay. So what's our final answer here? Calculators, final answer is going to be what? So 0,5 times 0,5 times open brackets, that is 11,9 squared minus, okay, open bracket there, negative 20,38 squared as well, okay, squared, and then it gives us what here? It gives me negative 68,43. I get negative 68,43. Negative 68,43 joules. Now that's my energy which is lost. Why is it lost? It's negative. How was it lost? By the sound made by the heat as the ball struck the ground. Hope we are together. Next question here. They say the time taken for the ball to reach point P after leaving the ground. Now I want the time to reach point P after leaving the ground. So this time now, what am I supposed to do? Now at point P, my velocity there is 0, right? Here at point P. Is point P the maximum height? Let's check the question again. What are they saying? They say the ball strikes the ground and bounces vertically upwards, reaching a maximum height. Did you hear that? Reaching what? A maximum height again. Where velocity is what? Is 0. Okay.
7.1.2.
So
don't forget
now the V initial is the V for bouncing.
Positive charges,
so
Q1 and Q2.
My V initial
meters, 0,02 meters
bouncing,
apart. Okay.
What was it?
So here 0,02 meters
it
apart.
was the
And then
11,92.
They said
because
that
it is pointing upward,
the charge
positive.
of
So it is
Q1
positive,
is twice that of Q2.
Positive 11,92.
And the force between them is what? It
then
is
velocity at
9
maximum height we see it is 0. Okay.
Then
And
point
then what I'm looking
P
for the
is
change in time.
0,02 meters away. This point P
Alright.
from
So
Q2 as in
what
the
am I
diagram
supposed to do?
illustrates here.
I'm gonna
They say
say
that
V final,
7.1.2
okay, equals
they
to
say
V initial
that
plus
calculate
A
the net electric
change
field
in
at
time.
point
So
P
V
due to
final
charges
0.
Q1 and
Okay.
Q2.
V initial
So
was the
we want
11,
the E
what?
net at P.
11,92.
We want what?
Okay.
The E net
Then
at
plus
point P.
the negative
So this point P, we want the E
9,8.
net.
Okay.
Okay.
Times change in time, which
The
I'm
E
looking
net
for.
at
This
P.
one now becomes positive.
So now for that
side,
matter,
so I have
don't forget our
9,8
E net.
T
Our E net
equals to 11,
our
what?
E net at P.
11,92. Okay. So divided by 9,8, guys. What do you get? Calculator.
Is given by the E.
Divided by 9,8.
The E.
My change in
due to
time
charge Q1
becomes
plus
what?
the E.
Let's take it out here.
Due to charge
On a
Q2.
calculator.
But because we don't know the charges yet,
11,9.
let us first find the charges Q1 and Q2.
Divided by 9,8.
Now the force given here is Coulomb's force. Okay. The formula says that
it gives us
the
1,
force
2
equals to K
1, 2,
times
1.
Q1
1,
times Q2 divided
here,
by what?
1,
by distance squared.
2,
now
1.
the force given here is 9.
That's my time to reach maximum height.
Times 10 power
next
negative
question
3.
Here says what now?
Equals to K. What's
Let's
our
check
K?
it out.
9 times 10.
They said that
Power
now,
9.
You know what?
Then our Q1 and Q2.
The velocity time graph for the motion of the ball from the instant it is
now
projected upwards from the
because
top edge of the building
they
until
positive
the time it reaches
charges,
the
all of
point
them.
P is shown below.
What do we do in this case?
Write down the numerical
going to
values
say that
indicated
our
by each of
Q1
the
is twice
following.
Q,
That is
okay?
K,
Like you see
L,
it here.
and T2 minus
We're gonna say our
T1.
Q1 is what? Is
Now,
twice
carefully,
Q.
listen carefully here, my friends, my
Our Q1 is
students
twice Q.
of roasted
Then our
wherever you
Q2 is
are.
just Q, okay?
Now you see this
Divided by the
point
distance
L
squared, which
is
is
our
what?
V initial.
0,02.
That's when the velocity, the ball was projected upwards. It went
must
up
be squared,
where maximum,
okay?
where velocity
So we're
at
gonna
maximum
say
height
here
is
it's gonna
0.
be,
This maximum height here,
if I
where
cross
velocity is
multiply
0,
here,
then from maximum
multiply
height,
this one here,
the
I'm gonna
ball
say
went
that
and struck
9
the ground. So
times
here velocity were
10
striking the
power
ground.
negative 3,
And when we are
okay?
bouncing from the ground now,
Times
in this
0,
point here, So this point K,
0,
we have
2
the velocity
squared,
from what?
okay,
Velocity of bouncing,
divided
which we talked
by
about here. Then this time
this
T2,
2,
when we
okay,
reach maximum height
10
again.
times
Okay.
9
So the T2
times 10
minus
power
T1
9
is
equals
actually,
to q
which we just
squared.
got now as
Okay,
1 comma
now
21.
calculators, get me the
1
square
comma
root.
21. So
What do you get
this
here?
is 1 comma 21. They said give
Now we
numerical
see
values. This is
on my
1 comma what?
calculator
1 comma
the q
21.
squared.
Now the
Okay,
K and the L,
the q
let's check the
squared
K
equals
again.
to
Our K is velocity for
the q
bouncing.
squared.
What did
Yeah,
we say was our V
the q
bouncing? Do you
squared,
remember that,
q
guys?
squared
It is 11 comma
is
what?
equal
11,92.
to
So we're
2
going to put
times 10
here
power negative 16. 2
11,92.
times 10 power negative
11,92. Okay.
16. So now I need to
11,
find square root. Square root on both sides.
11,92.
Square
Okay.
root.
What
Okay.
about L? That was
So
our
what
V
is our
initial in our
q equals to?
calculations. What was our first answer
From
there?
my
Which
calculator
people
here,
remember it?
I'm getting
It
my
was
q as
oh
like
Jesus.
this. My
It was
q
what?
equals to 14.
Sorry about
Okay,
that. What was it? Let's
14,
take it in.
comma
It was the
142,
10,74.
142,
Oh, thank you,
then times
Jesus.
10 to the
10,74.
power
So this is
negative
10,74. This
9.
is our L here.
Power negative
I
9.
hope we
Okay.
are together.
Now these are
This is
coulombs.
Petri Kamala,
After getting the
a
value of
tutor
q, I come back
and
and get to get
educator
now the
for
E
psychology
due
Polukwane.
at P
If
due to
you
Q and the
want more
Q2. Okay.
information
So
regarding our
don't forget
tuition
that we
center,
said that our
you can
E
call us on
at
0785
P, okay,
222
the E at
041.
P equals to
However, I think we are
the
moving
E
on. Next question
due to
here.
charge
That
Q1,
is
okay,
question 4,
times the E due to charge
November
what? Q2
2023.
divided by
What
distance
was it
squared
talking
from
about?
P,
Let's
okay.
check it properly here. They say here that a
Beg your
wooden
pardon,
trolley
yeah.
of mass 2,7
Alright, now
kg
how do you find the
moves to the
EQ1?
left with a constant
Now the
velocity, okay, of 3
EQ1
meters per
given by
second.
K
A bullet of mass
times
0,03
Q1
kg is fired
divided by the
horizontally
distance squared
from the left
also
toward the
plus
trolley.
K
Okay, see
times
diagram 1,
Q2
this one here. They
divided
said
by
the
what?
bullet
By distance
strikes the
squared.
trolley and comes to
So in this
rest
case,
inside
don't
the
forget
trolley
our
in what?
Q1
0,02
replace
seconds.
Q,
The
and we
average
just got
net
our Q,
force
okay?
exerted by the
We just
trolley
got
on
our
the
Q
bullet during this
as
time is
14,
what?
1,
It
4,
is
142 equals
591
negative 9.
Newton.
Okay, so
The bullet
we are going to say
trolley
that our E
combination
due to
now
P
moves to the right.
at P
See
equals to
diagram
K.
2.
Our K is 9
Okay.
times
They
10
say here that
to
a
the power
wooden
9. Now it's
trolley
our
of
Q1.
mass
Now our Q, we said
2,7
is twice
kilograms
Q, so it's going to be
moves
2,
to the
okay?
left with a constant velocity.
2 times
You
our
see this
Q, which
this
is
this wooden
14,
trolley here
okay?
to the left,
Comma
okay? Velocity of 3
142,
meters per second.
142
Then a bullet, this
times
bullet here
10
of mass
to the power
0,03
negative
kg
9, okay?
is fired horizontally
Then
from
divided by
left,
the
okay,
distance, which is
towards the trolley.
now distance from
The
Q1
diagram
to
1 here.
point P.
Then the bullet
Let's
strikes
check
the
it here.
trolley. You see it
Now
is inside the
Q1 to
trolley here,
point P is 0,
and it comes to
0.04
rest in which how
meters,
much time?
but must be squared,
0,02
okay?
seconds. Then the average
0,
net
okay?
force exerted by the trolley on
0,04
the bullet.
meters,
Now the
but
trolley
must be
was going to the
squared.
left,
What about due
which
to
means
Q2?
it
We're
must
going to say
exert a
K,
force to the left.
K, okay,
Okay,
which is
which
9
in this case is what?
exponent 9, okay?
591 newtons.
We're going to
Okay,
say K,
then they
which is
say
9
the bullet
times
trolley
10
combination
to the
now
power
moves to
9,
the right. You see
and
it going to
then,
the right now. Okay,
I beg
all
your
right, what
pardon.
must we do? They say ignore all
Yes,
friction
we're
and
saying that
rotational effects. Okay,
9 times 10 power 9,
4.1.
10
Write
times
down the magnitude
Q2.
and
Now Q2
direction
is
of
the
the
same as
average net
Q, so
force that the
I'm going to
bullet
say
exerts on the
14,
trolley.
okay,
Now,
comma
the bullet
142
exerts a force on the
times
trolley,
10 power
and
negative
also the trolley
9
exerts a force on the bullet. Okay,
divided by the
because we have
distance.
the
Now
force
the
of the trolley
Q2
on the
from
bullet,
P,
which
let's
is
check the distance
591
again.
newtons to the left,
Now from
mean that the bullet will
P
exert the
to
same force
Q2,
on
as
the
you can see,
trolley
0,02
of
meters. So I'm going to say here
591 newtons, but to the what?
0,02
To the
meters.
right.
So this
So
is
our answer is what?
0,
They said
comma 02 squared.
they
Okay.
want the magnitude and direction.
Now from my
So you're
calculator
gonna say
here,
magnitude
my E at
591
P, let's find
newtons.
out here.
Okay.
My E at P,
What about direction?
calculators,
To the
there, what do you
right.
get?
Okay.
Here I get
Why are we saying so?
9
Because
exponent
of what?
9
Newton's third
times
law of motion. How do we state
2
it? If body A exerts a
times
force on body
14,
B, then
comma
simultaneously body B
142
exerts the same
exponent
force on
negative
body A
9,
of
okay,
the same
then divided
the
by
opposite direction. Okay. Now they say here
0,
4.2. Calculate the magnitude of the velocity
squared. Okay.
with which the bullet
Here it
strikes
gives
the
me
trolley. I repeat,
159097.
calculate
So for the first one here, I
velocity
get
with which the bullet strikes the trolley.
15. Okay.
Velocity with which
90
what? The bullet strikes the trolley is what I'm looking
97.
for. Okay. So now
97,
regarding the
5.
bullet, guys,
Okay.
as you can see, I
Here I
know
get
its
now
mass,
let me
right?
check some other one.
But
Now
I
here I
don't know
have
any of the
9 exponent
velocities.
9 again.
Okay.
It's 1,
But for the
4,
trolley, I know its mass.
1, 4,
I know
2
the V initial.
exponent
Okay.
negative
And
9 divided
I know
by
the
0,
force
0.02 squared.
it exerts on the bullet.
It
So,
gives me
in other
3.
words, the question is asking
I
for
get here
the
3.
velocity at which the bullet strikes the trolley.
181,
And I said with the bullet, I
31,
only know the mass, and also I also know the
95.
force
Okay.
it exerts on the what?
Then
On
now,
the trolley,
because
but I
they
don't
are
know
both
anything
positive,
else. Also know the
they're going
time
to be in the
here.
same direction
So
from
now I'm
Q.
going to use
So
the
we
trolley
just
because
add
I
them
know
in this
its
case.
mass, and I know
Okay,
the V
so if we
initial,
add the first
and I know
one,
the force, the net
so it's
force,
plus 1,
and I
5,
know the
plus
time,
1,
so
5,
that I can find
9,
my final
0,
velocity of the
9,
trolley.
7,
And because they are
5.
moving together,
It
that
gives
will be
me a
the same
total
velocity
of 4,
of the
7,
bullet.
7, 2, 9,
So I
2.
will be knowing
So I
final
have here
velocity
what?
for the
This
bullet,
is
and I'm
4,
gonna use it to know the
7, 7,
initial
2,
for the bullet. So
7,
here we
7,
go.
2,
Now
9,
that I know
2,
the mass
then
of the
comma
trolley
5.
and the
Okay.
force, okay.
Now E is measured in
All right.
newtons per
So what
newtons
do we
per watt,
say
newtons
here?
per coulomb.
Because we have F net. Hope
Okay,
you
now
notice
because they are
if we
both
say
positive,
our F
it
net,
means that
okay,
they are
F
repelling
net
the
equals
positive
to
test
what?
charge at P.
F net equals
So it's
to
going to
change
be
in
towards the
momentum,
east.
okay,
Okay.
divided by change in
So we're gonna
time,
say east
okay.
here.
So what's our F
We're going
net?
to say
5
east.
what? It is
We're
591,
going to say
okay.
east.
What about change in momentum?
That's our
It
answer
is
there.
mass
The E
of the
net
trolley, which is
at P.
V, which is
That's what we
2,7
get there.
times velocity of the trolley. So
Okay,
here
next
we
here.
have our V final, which we don't know yet for the trolley. Now the V initial was given to us as
they're
what?
saying that
As 3.
that is now
Because it's going to the
7.1.
left, I'm going to say negative
Yeah,
3 because I'm
7.2.
taking the right as positive.
Two
Okay,
small
so now in
spheres
this
A
particular
and B,
case, so I say
they are fixed in a
divide
place
by
and
change in
supported
time,
by
which was 0,
2 exponent
what?
negative 2 meters
0,
in a vacuum. Sphere
zero
A has a charge of
seconds. Let's
positive 1
confirm
exponent
that here.
negative 6, and
0,
sphere B
0,
has
you
a
can see it
charge
here.
of
So now
negative
if I
1 exponent
calculate
negative
here,
6 coulombs,
I
as
can
shown in
get
the
my V
diagram below.
final. So I'm going to say
State coulombs
that
law
is
in
5,
words. How do we
another
state it?
591
The electrostatic
multiplied by
force between 2
0,
point charges is what?
0.02
Directly
divided by what?
proportional
By
to the
2,7
product
equals to
of the
V
magnitude of their
final, okay,
charges
then
and
plus
inversely
what? Plus 3.
proportional to the square
So
of the distance between their
calculators,
centers.
what's my
Okay.
V final
Then
from
they say
here?
here calculate the number of excess
Let's work
electrons
it
on
out.
sphere B. Now
Fraction
sphere B, we
button.
need the number of
Let me
excess
say
electrons. How do we find them?
591, okay.
Because we have the charges there,
591 multiplied
we know
by
that
0,
all the
0.02
charges are
divided by
quantized,
2,7,
okay,
and then later
meaning that
subtract what? 3. So
we
here
can
it
say
gives
that
me
for any given charge on sphere
1,38.
B,
So I get
to find the number
1,38
of
here
electrons, we say
as my V final.
that number
So
of electrons equals to the
1,38
charge
1,38
on sphere B
is the velocity
divided by the
final
atomic
for the
charge.
what?
So we're gonna say
For
that
the
it's gonna be
combination.
N equals
Also the
to here they
velocity
gave us
final for the
negative 1,
bullet and the trolley, because
comma
they
0
are
times
stacked together.
10
Now that I
power
know this
negative
V final
6.
for the trolley, which becomes the
Now
V
the
final for
charge
the
on electron
bullet,
is how much? It's
then why not?
1,6
I can go ahead. They say calculate
times
what?
10
The V initial for the bullet.
power
Ne?
negative
But
19.
because of
So it
linear
gives us how
momentum
many electrons here?
conservation, what should I say?
Let's check it
I'm
here.
gonna say that here, as you can see, I'm gonna
Calculators,
say
what do you get here?
M1, okay,
We
V1
have
initial
one exponent
plus
to negative 6
M2
divided by
V2 initial.
1,6
Because they are stacked
exponent to
together, I'm gonna
negative
say now
19,
M1 plus what? Plus
which gives
M2
us here
times V
6,25,
final, which I just
which
got
gives
now,
me
okay? So now
6,25
the mass for the
is
bullet I know 0, what?
25
0,03,
times
okay?
10
I'm looking at
power
this
12
V initial,
electrons.
then plus mass for the trolley, which is 2,7, okay? What about V initial? Negative 3, okay?
Okay, then
Equals to, in
7.2.3.
brackets here,
They say using a
0,03,
suitable
okay?
Plus
Plus 2,7,
show that the number of
2,7.
electrons that
Then this V final, that's what I just
must
got now,
be
guys, ne?
removed from
which
A,
is 1,38.
and
Okay,
put
so I'm
onto
saying here
B to make the
times
demonstrative
1,38.
force that
So
acts on each
times
sphere.
1,38.
Negative force
So
whose magnitude is
what's my
45
final answer
kilonewtons
here?
is equal
So
to
because of the minus
2,
here, it's going to become positive this side.
59.
Then I'm going to divide by
Okay.
0,03 and get my initial for the bullet. Okay. So calculators there. Here we go. We are going to say that open bracket. Okay. Fraction button, open brackets. Then 0,03 plus what? 2,7 close bracket times 1,38. Okay. Are we together? So in that case, what do we get there for our first answer there? That one there. Then after getting 0,1178, we're gonna say plus what now? Plus 2,7 times what? Times 3, okay, which gives us 8,21 here. Then we say divided by 0,03. So here it gives me 273,73. It gives me what? 273,73. That is 2, okay, 273,73, okay. All right, because they say the velocity, we must say it is to the right, okay, because they want to mark the direction, okay, both of them. Here they say that I state the principle of conservation of linear momentum in words. Now listen carefully here, guys. If you ask for this statement here, what we say that the total linear momentum in a closed system is conserved. I repeat, the total linear momentum in a closed system is conserved. Please don't say that the total linear momentum before collision is equal to total linear momentum after. That's not marked correct. Okay. Now they say here, calculate the amount of the velocity of the bullet trolley combination after the collision. Now this 4.4 is what I did before exactly. So what we're talking about here, the 4.4 is what we see here as well. This is 4.4. You can do it like this exactly, okay? You can do it like this exactly. This is 4.4 as well, because asking for this answer here, okay? Which is meters per second, okay? To the right. That's our answer there. All right, hope we are still together. Let's move on, guys. That is question now, question 5. Question 5 here. Okay, they say that learners conduct an experiment to determine how the initial kinetic energy given to a trolley affects the distance the trolley moves on a rough horizontal surface. A learner pushes a trolley of unknown mass until it reaches point A with the kinetic energy EK at A. The horizontal distance delta x traveled by the trolley before it comes to rest is then measured. See the diagram below. I repeat, learners conduct an experiment to determine how the kinetic energy initial given to a trolley affects the distance the trolley moves on a rough horizontal surface. A learner pushes a trolley of unknown mass until it reaches point A with kinetic energy EKA. Then they said that the horizontal distance delta x traveled by the trolley before it comes to rest is then measured. See the diagram below. So when the trolley reaches here, it continues until it comes to rest. Okay. Now they said that the experiment is repeated with the trolley moving on the same horizontal surface, but with different initial kinetic energies. But with what? But with different initial kinetic energies. Okay. Now they say here that what must we do? Check here. What do we have on the y-axis? This is distance traveled. Okay. What about x? This is initial kinetic energy. Now here we don't have final kinetic energy. Why? Because it comes to rest. So it means final kinetic energy is 0. So what must we ignore at this time? Ignore rotational effects of the wheels of the trolley. They say draw a labeled free-body diagram showing all the forces acting on the trolley during its motion after passing point A. Okay. They are giving us 3 marks here. Now this trolley, it is on the surface, okay? So guys, if this is the surface here, like I said, begin with the surface, né? If this is the surface here, which is horizontal, okay? Then if they say free body, you put no body, but put a dot. But put what? A dot. Now, being a tool with a mass, it has weight. So the weight is acting vertically downwards, okay? That's our weight there. Okay, that is our Fg, which is the weight in this case, okay? Then from there, being on the surface exerts a normal force, okay? Exerts what? A normal force, okay? All together. Now the normal force is normal, meaning it is what? Perpendicular. So it's our F normal here. It's our F normal. Then if it's going to the right, what's going to be our frictional force? It's going to be to the left. So this is our frictional force here. This is our frictional force here. All together. Frictional force here. Now frictional force is on here, okay? All right, so because it is past point A, we don't have any applied force anymore. So if I remove my surface now, I'm left with my free body, okay? So in this case, this is our frictional force, which is Fk, because the body is moving, okay? This is F normal, this is weight here, which is Fg. All right, let's say, name the independent variable index in this experiment. Now listen carefully, guys. To get our independent variable in the experiment, we check what the experimenter is changing. So in this case, these learners, what are they changing? They are using different initial kinetic energies. So that must be our independent variable. Why? Because by definition, independent variable is a physical quantity which the experimenter changes. So here, our IV is going to be what? The different initial kinetic energies. So here our IV is what? It is the initial kinetic energies, okay? It is initial kinetic energies, okay? State work energy theory in words. How do we state it? The network done on an object is equal to the change in the object's kinetic energy. I repeat, the network done on an object is equal to what? To the change in the object's kinetic energy. So they say now I'm 5.4. Calculate the mass of the trolley if the coefficient of kinetic friction between the wheels of the trolley and the rough horizontal surface is what? 0.18. Now, if it asks for something up here, that's for the work net, we know that our work net, okay, from above there, equals to change in EK. Equals to what? Change in EK. Now, in most cases, when that's for the theorem, you want to use it in the following question, okay? We're looking for the mass of the trolley, okay? And they gave us coefficient, that is 0.1, I think 0.18, okay? Now, from our graphs there, what do we have? We have a graph of the displacement versus initial kinetic energy. So this displacement here versus the initial kinetic energies here. So to get our mass of the trolley, what do we do here? So here we go. We are going to say that our work net equals to what? Change in EK. Our work net equals to change in EK. Okay. Now, what does change in EK mean to us, guys? Change in EK means you get the kinetic energy, which is what? Which is final, minus EK, which is what? Which is initial, okay? Then in this case, because as we saw in our flow diagram, the only force acting horizontally is what? It is this one here, which is the force of friction. So we're looking for the work done by frictional force. So we're gonna say here that's gonna be the work done by what? By Fk. So how do we find it here? We said it's gonna be our Fk, okay, multiplied by the displacement, okay, then times what? Times cos of theta, okay, equals to Ek final, okay, Ek final minus what? Minus Ek initial. So here we go. Now, if we take a pair here, let's take this 18 which corresponds to what? 4,5, okay? Now in this case, I don't know the frictional force, but I know it's given by what? By coefficient, okay, times normal force, which in this case is same as our mg, okay, then times our displacement, okay, then times cos 180 being friction equals to ek final. Now ek final here is not here. Why? It comes to rest, so ek final is 0. Now the ek initial here, which I have, is 18, okay, so here the coefficient was what? 0,18, right? Then times the mass, which I'm looking for. What about my gravity? That's 9,8, okay. What about my angle? My angle is what? My angle is cos 180. So this is cos 180 degrees, okay. Then equals to negative what? Negative 18. So here, now 0,18 times 9,8 times cos 180, calculate as what we get. 0,18 times 9,8 times cos 180, we get here, oh Jesus, I forgot our displacement here, delta x, which is correspond to 4, so times 4,5, 4,5 as well here, so times 4,5 times 4,5, it gives me here 7,938. So I have here 7,938. Now it comes with m, but negative because of negative cos 180, so equals negative 18. So divide negative 18 by that answer there. So if I divide negative 18 by the answer here, which I have, I get actually 2,27. So my mass for the trolley is 2,27 kilograms. I hope we are together. What else do we need here? Let's check it. That was question 5. Okay, we go to question 6 now. Question 6. Question 6. Question 6.1. Question 6.1. An ambulance is moving away from a stationary listener with a constant velocity of what? Of 25 meters per second. The siren of the ambulance emits sound waves at a frequency of 550 Hz. The listener detects the frequency of these sound waves to be 512,64 Hz. Okay, ignore the effects of wind. State Doppler effect in words. How do we state it? It is the change in frequency of the sound detected by the listener because the what? Because the sound source and the listener, they have what? Different velocities relative to the medium of sound propagation. I repeat, how do we state Doppler effect? It is the change, okay? It is the change in frequency of the sound detected by the listener because the sound source and the listener have different velocities relative to the medium of sound propagation. Hope you got it, guys. They say here, use the information to calculate the speed of sound in air. Now, if you look at what we have here, they said that an ambulance is moving up from a stationary listener. This RV listener is 0 because they said it's stationary. Okay, and then with the constant velocity, this is the velocity for the source. This is V source here. Okay, and then they said the siren of the ambulance emits the sound waves of at what? At this frequency. So this frequency here is our frequency of the what? Of the source. That is the 550. Okay, frequency of the source. And then what about the one which is detected? That our F listener is this one now here. This is our F listener, the 512. Okay, 512 is our F listener. This is our F what? Is our F source. Okay, so which must we calculate? They say here that the speed of sound in air. Okay, So we're looking for V in our formula. Now, because the sound source is moving away, what do we say? This formula says that our F listener, okay, F listener equals to V, okay. Because of moving away, we say minus V listener divided by V plus V source, okay. Then times what? Times F source. Times F source, okay. So in this particular case, let us do substitute here. If we do substitute here, what do we get? You're going to get this is V source here. Now our F listener is 512. That is 512, 64, 512, 64. Okay. What about this V? You're looking for this V, the speed of sound in air. Okay. Now this guy was stationary. I'm gonna put 0 here. Minus V, okay, plus 25, which we saw up there. Okay. Then frequency of the source was given as what? 550. Okay. This is 550. All right. So from here, I'm gonna say that this V plus 20, I'm gonna cross multiply. Ne? I'm going to do what? Cross multiply. I'm going to say 512. Okay. 512, 64, open brackets, V plus what? Plus 25 equals to 550V equals to what? 550 times V, okay? Now open brackets here. What do we get, guys? Open brackets here. What do we get here? Now if you multiply the 512,64 multiplied by 25, what do you get, guys? 512,64 times 25. Here it gives me 12816. I get 12816. So this is 128, okay, 16, okay. Then with the V, okay, but it comes on the other side, né? So equals to 550, okay, 550V minus 512V, 512,64V, okay. So divide the 12816 divided by the difference there. So this is 12816 divided by 550 minus 512,64. So my V becomes 233. I mean 343,04. So here my velocity becomes what? My V, I get what? I get 343, okay, 343, what? 343,04. That's the speed of sound in air, okay. Next question here, they said that if the ambulance moves away from the stationary listener with a constant velocity which is greater than 25, maybe 30 or 35, how will each of the following change? Choose from increase, decrease, or remain the same? The speed of sound in air. Now, the speed of sound in air does not depend on any of these listener or source moving, so it remains constant. Okay, remains what? Constant. So here we are gonna say it's gonna remain constant. There's not remains the same. So here we say remains the same. Remains the same. Okay, remains the same. What about the frequency of the sound waves emitted by the siren? Also remain the same. Okay, remain the same because the frequency of sound source is determined by the person driving the train. Okay, they can make it more or less. Okay, then here we have the frequency of the sound waves detected by the listener. Now for this particular one, because of Doppler effect, it will decrease. It will do what? Decrease. Remember that if the source is moving away, you're going to have very big or very large wavelengths, and the larger the wavelength in that case give us what? a smaller frequency. That's why it decreases. They say here 6.2. The spectrum of a distant star when viewed from Earth is red-shifted. Is the star moving away from or towards the Earth? So in this case, what do we know? Now, when the view is red-shifted, we know it is moving away from the Earth. Okay. They say now use the Doppler effect to explain the answer to question 6.2.1. So what do you have to say? Okay. Now in this particular case, because they said a distant star when viewed from the Earth is redshifted. Now that means that in that case we have a lower frequency has been detected. A lower what? A lower frequency has been detected. Lower frequency has been detected because if you check on the spectrum, the one with the lower frequency is the end of the red, is the red end with the lower frequency. Are we together? And so, because of that, then the spectral lines are shifted to the red end of the spectrum. Okay, the spectral lines are what? They are shifted to the red end of the spectrum, and so that's why it is going to be what? It's going to be away from. Don't forget that with Doppler effect from our Doppler equation, if F listener is lower than F source, then the source is moving away. All right, hope we are together. Let us proceed. Question 7. Question 7. Question 7, they say here that 2-point charges A and B, each with a charge of positive 3, exponent -9 coulombs, are stationary on a horizontal surface. Point P is R meters from charge A and 2 R meters from charge B, as shown in the diagram below. Define an electric field. So what's electric field? Electric field, it is a region, or you can say space, okay? We say it is a region, or you can say what? Space, where an electric charge, okay? Where an electric charge experience what? Will experience an electric force. Will experience what? An electric force. Okay. The next question here says that draw the resultant electric field pattern due to the charges A and B. Now our A is positive, our B is also positive, okay? So because they are both positive, they're going to be repelling each other, and because we use a positive test charge, the repulsion must be outwards, okay? So it will look like this. So now in this case, that is 7.2. Let me draw it here. 7.2. You must indicate the positive, okay? If this is our A, which is positive, and this is our B here, which is also positive, okay? Then the lines are, they're going to be repelling, they're approximately tangential from the surface, okay? So they are repelling, and don't draw so many, please, guys. Don't draw so many, okay? Don't draw so many. And because they are the same magnitude charges, we put the same number of what? Same number of the lines, okay? These field lines coming from the surface. Okay, so yeah. Now because we use a positive test charge, they're going to be pointing outwards, né? So it's pointing up like this, pointing up here. So they're pointing outwards, meaning they are being repelled, okay? Pointing upwards, and pointing upwards as well, pointing upwards, and like that, okay? Now they say, what must we do? They said here that the magnitude of the net electric field at point P is 27 newtons per coulomb. Calculate the value of R. Now this point P here, which if you can see it guys here, is we are looking. They gave us the E net at point P, which is 27. Okay, so we have here the E net at point P. Okay, which is 20 what? 27 newtons per coulomb. Now, if we put a positive test charge here, we are going to experience the E net at point P because of charge A and because of charge B. So the formula is going to be like this now. Check it out. Our E net at point P, okay, our E net at point P, our E net at point P is the sum of the electric field because of what? Because of charge A plus the electric field strength because of what? Because of charge B. But the E net given to us is what? Is 27, okay? Now, how do we find the E at because of charge A? We use K times what? Times charge A divided by the distance squared, okay? What about there? We use what? We use K times the charge B divided by what? By distance squared, okay? Let us now substitute. This is our 27 here, okay? Then our K does not change, 9 times 10 to the power 9. Now the charge on is same as charge on B, so it's going to be 3, okay? So times 3 times 10 to the power negative what? Negative 9. So divided by the distance. Now the charge A from P, how far is it? It is R, right? So we're going to say divided by R squared. Divided by R squared, okay? So this is R squared here now plus. Now the E at because of charge B, again I'm going to use K, which is what? Which is 9. 9 times 10 to the power 9. Now the charge on V, some of the charge on A, that's going to be 3 times 10 to the power negative 9. Okay. Now my distance of charge B from point P, let's check it again. It is 2R. So divided by 2R and then I square divided by what? 2R squared. Okay. Now here, what do I? It's going to be now 27. Okay. Now if you check here, they're going to cancel these exponents. So 9 times 3 gives me 27 divided by what? By R squared. Okay. Then plus, what about here? Again 27. Okay. Divided by 4 R squared. Okay. So that's what I have here. But now before I continue, I must know my directions. Are they going to be all positive or negative? Now bear in mind that we use a positive test charge. We use what? A positive test charge. So for example, if I put my positive test charge at point P here, okay, then the E due to A is going to be repelling it, okay? So it's going to be facing where? To the right. This is my E because of what? Because of A. So my E, as you can see, it is pressing to the what? It's pushing it to the right. So it must be made positive. So the E due to charge A is what? Is positive. So this is positive here. Okay. Now look at the E due to charge B. Let's check it now. So if I put a positive test charge here again, like I told you before, put a positive test charge here, positive here. Now the E, because of charge B, this charge B is also positive. It's going to repel this one here. So it's going to be facing where? It's going to be facing to the what? To the left, okay? So this is the E because of what? Because of the charge B. So as you can see facing this side, so it's going to be made negative. So my answer for the E because of B must be what? Must be negative, okay? So when I come here, I'm going to put a minus here, okay? I'm going to put what, guys? I'm going to put a minus here. So it's a minus here. All right. So, yeah, we continue now. We can go ahead. Now the common factor here is 27. So I can say that 27 equals to 27, okay, open brackets, left with 1 over r squared, then minus 1 divided by 4, also r squared in this case. So if I divide by 27, they're going to cancel here, okay? So I have 1 equals to, now in mathematics, 1 over r squared minus this one here. To create the 4, it's going to be 4 divided by r squared, okay? Divided by what? By 4r squared, okay? Like this. Then minus 1 divided by 4r squared, okay? So because I have the same denominator, I do subtract, okay? So what is 4 minus 1? It gives me 3 divided by 4 what? By 4r squared. This is my 1 here. So because I'm looking for the r squared here, I'm going to cross multiply. I'm going to cross multiply here, cross multiply. So what do I get here? I get 4r squared, okay? 4r squared equals to 3 equals, so divided by what? Divided by 4, divided by 4 here. After taking the square root, what's my r? Which they wanted here. Let's check it here. It's going to be square root of what? Of 3 over 4. Square root of 3 over 4. So what do I get? The square root of 3 over 4. Yeah, it gives me 0.87. So my r is 0.87 meters. 0.87 meters. That's my r. I hope we are together. Next here, we said that what must we find now? Let's check it out here. They say calculate the magnitude of the net electrostatic force that an electron would experience if placed at point P. I repeat, calculate the magnitude of the net electrostatic force that an electron would experience if placed at point P. Now our E by definition, okay, our E by definition, E, okay, equals the force which is experienced per what? Per charge, altogether. So in this particular case, we're talking about an electron, okay? So this force we're talking about here, that force will be given by what? By the E multiplied by what? Electronic charge. So in this case, the force which we have, the E which we have here, they gave us 27, okay? So 27. What about charge on the electron is what? Is 1,6 what? 1,6 times 10 power negative 19, okay? Power negative 19. So which answer do we get here? Okay, so 27 times 1,6 x negative 19. Here it gives me 4,32. It gives me here 4,32 exponent negative 18 newtons, okay, because I'm talking about the force here. That's the force which is going to be experienced by an electron placed at point P. Why? Point P has got that field which is of 27 newtons per coulomb. Hope we are together. Okay. Question 8. The circuit diagram below shows a battery with an EMF of 12 volts and internal resistance of 0.5 ohms connected to the 3 resistors, a light bulb, a switch, and an ammeter and the connecting wires. The ammeter and the connecting wires have negligible resistance. So this is our battery here with internal resistance 0.5, EMF 12 volts, this ammeter here. Here we have the 10 ohms in parallel, and this is the bulb with the 10 ohms as well. Then the switch S is here. State Ohm's law in words. How to state Ohm's law? The potential difference across a resistor is what? Directly proportional to the current through the resistor at a constant temperature. I repeat Ohm's law. the potential difference across a conductor is directly proportional to the current through the conductor at a constant temperature. Then switch S is initially closed like this, it is closed here. What must we calculate now? The total external resistance of the circuit. So now, total external resistance of the circuit, in this case, we're going to say that our total resistance external equals all resistors in series plus what? Plus resistors in parallel. So in this particular case, they are all in parallel anyway here. Now in this particular case, these arrow 1 and 2, they are 2 which are in parallel there. Now we said if they are 2, use product over sum. So we are going to say that that is the 10, okay, times 10 divided by 10 plus 10. Okay, what is 10 times 10, guys? You get 100, then divided by 20, which gives us what? Which gives us 5, okay? So mean that here, for these two, we have 5 ohms, these two combined give us what? 5 ohms. Now the 5 ohms here plus this 10, it gives us 15, and this 15 is in parallel with this 15 here. So again, we are going to say that again the 15, okay, multiplied by again the 15 here on top, then divided by the sum, that's also 15 plus 15. Okay, so what do we get here? So what is 15 times 15? Let me check it here. Actually, it gives me 7,5. So here I get 7, what? I get 7,5. So this is 7,5 here. 7,5 ohms. That's my total R external. That is 7,5. 7,5 ohms. Okay. All right. Now reading on the ammeter. Now ammeter reading here, because I know my external resistance and I know the EMF, I can find my ammeter. What do we know? That is 8.2.2, 8.2.2 EMF, okay, equals the current I, open bracket C, external resistance plus internal resistance. So EMF given to me is what here? It is 12. I'm going to say 12 here, equals to, and make the bigger pen here, equals to what? Let's check it out here. Equals to the current I which I'm looking for, okay, open bracket here. Now this C is 7,5 here. What about internal? They gave us what? 0,5, 0,5 here. So my current I for the ammeter reading is going to be 12 divided by what? By 8, okay? So what do we get here? Calculators. 12 divided by 8. It gives me here 1,5 amperes. So my ammeter is going to be 1,5 amperes. Okay, so this is 1,5 amperes here. Then they say the power by resistor R3. So we want the power here by resistor R3. And now note something here that this electricity when it is coming here from this ammeter, it is 1,5 amperes. Okay. So now when it gets here, it's going to divide. Some current is going to pass there, another will pass here. Okay. Now because this is 15 ohms, and what is 5 plus 10 is also 15, so it's going to be divided equally. So the 1,5 is going to divide here to give us what? Here it's going to be our I as what? As a half of that, which is going to be 0,75. Okay, 0,75. Even here 0, what? 0,75. Okay, so because of this, I know the resistance and the current, and I can find my power. What do you know about power, guys? How do you find it? Now to find our power here, we said that depending on the available information, like in this case, we are going to use our power equals to I squared, okay, times what? Times resistance. So what's my I here? 0,75. So we say 0,75 squared, okay, times what? Times 15. So what's our final answer here? Calculators, 0,75 squared times 15. It gives me 8, 8,44. I get 8,44 watts here. I get 8, what? I get 8,44 watts. Okay, that's my power. Now they say here that the switch S is now opened. If the resistance of the light bulb remains constant, how will the brightness of the light bulb be affected? Choose from increases, decreases, or remains the same. I repeat, if the resistance of the light bulb remains constant, how will the brightness of the light bulb be affected? Choose from increases, decrease, or remain the same. Now, if the switch is now opened, okay? So if the switch is now open, it means that there's no more current passing here anymore. Okay, so mean that this part which I'm putting in red is out of action because no more current is passing here anymore. Are we together? So if no more current is passing here anymore, it means that my total resistance now, instead of being remember it was what? Remember it was, let's check it out. It was, what was the total resistance? It was 7,5 ohms. Okay, it was 7,5 ohms when the switch was what? When the switch was closed. But now the switch is open. Now I'm left with the 10 plus 5, which is 15 ohms. Okay, now the 15 ohms are more than the 7,5 ohms. So mean that because of the higher resistance, I'm going to get a lower current passing through the battery. I repeat, because of the higher what? Resistance, I'm going to get what? Less current passing through the battery, and because of it, I'm gonna lose less volts, and I'm gonna have a lot of V external, and so because of the high V external, my brightness is gonna increase. So what do we say here? We say that the brightness will increase, so we say it increases. Okay, we say it increases. Okay, that's our answer there. Brightness does what? It increases. We say it increases. Now they say explain the answer. What do we know? Now that the total resistance will increase. Okay, the total what? Total resistance will increase. Now if total resistance increases, it's going to affect the current through the battery. So I mean that the main current will do what? Will decrease. Now, if the main current decreases, then it means that our V lost due to internal resistance, our V lost will do what? Will decrease. So if the V lost decreases, then what happens to the V external? So the V external will increase. The V external will do what? V external will increase. So V external increases, and this one leads to what? Leads to increase in the brightness of the light bulb. Okay, increase to the what? To the brightness of the light bulb, because now we have a larger power output. Okay, yeah, that's that, guys. I don't know if we are still together or you have got a question. Okay, yes, question 9 November 2023. They say here that a simplified diagram of a DC electric motor is shown below. Okay, this is the south pole of the magnet and the north pole here. This is a split ring commutator. This is A. Okay, what are we supposed to do then? Let's check it out here. Write down the name of component A. Now component A is the what? The split rings. The split rings. Okay, as you can see, they're split. They're the split rings. Okay, and then they say here state energy conversion that takes place in this motor. Now a motor, it converts from electrical energy to mechanical energy. So converts from what? From electrical energy to what? To mechanical energy. From electrical to mechanical energy. Okay. All right. Then in which direction will the coil rotate? Choose from clockwise, or for the coil to rotate faster, you can use stronger magnets. You can use stronger magnets, okay, stronger magnets, or you can use what? You can increase the number of turns of the coil, meaning increase the surface area. So you can increase what? The number of turns of the coil. Number of turns of the coil, okay? So I get a larger surface area. Let us continue here. Then they say next that the circuit diagram below shows an electric kettle and a toaster connected to an AC source with an RMS voltage of 220 volts. The ammeter connecting wires and the switches they have negligible resistance, so that is zero resistance, and you can see this is our AC voltage ammeter, switches 1 and 2, kettle and toaster. They say define the term root mean square current. Define the term root mean square current. Now listen carefully here. We said that the root mean square current is defined as the AC current, are we together, which dissipates the same amount of energy as an equivalent DC. Are we together? I repeat, what is root mean square current? We're saying that it is the alternating current that dissipates the same amount of energy as an equivalent direct current. I repeat, root mean square current is the AC current that dissipates the same amount of energy as an equivalent direct current. Okay, next question here. What are they saying? They said that calculate the root mean square current in the circuit. So they gave us the one which is maximum. So this is I maximum here. This is I maximum given to us, which is 3,6. So our I root mean square, I hope you remember the formula. IRMS equals to what? Equals to I maximum, okay? Divided by what? Divided by root 2, okay? So in this case, what's maximum given to us here? They gave us what? 3,6, okay? Divided by what? By root 2. So what do you get? Calculators there? Please help us. Somebody the calculator. Here I get that is 3,6 divided by what? Root 2. It gives me 2,55. So here I have 2,55. This is 2,55 amperes. Okay. Next they said that when switch S1 is open and switch S2 is closed, the root mean square current in the circuit is 2,62. Okay. Then calculate the energy consumed by the toaster in 2 minutes too. The time is 2 minutes. Okay. Which means we can say it is 2 times 60. To put it in seconds, that's 120 seconds. Okay. We're looking for the energy W. Now energy W is given by the power times change in time. Okay. So because we have the current, and we have the voltage. Okay. So what do we do in this case? Okay. We have what? We have the power. We have the okay. If you check what we have here, they gave us our VRMS, which is 220. Now, that was the VRMS given here. They said that with RMS voltage of what? Of 220, we're looking for the work, for the energy. Now, that work done, all the energy dissipated, when they give us the time, so, and we know the RMS. So note that that is power times change in time, but what is that power given by? It's given by VRMS times IRMS times change in time. Okay, so in this case, what is our VRMS? It is 220. Okay, 220. What about our IRMS? It is 2,62. What about our time in seconds? It is times 120. Okay, so what do you get? Calculators there? What do we get here? I am getting on my calculator. If I check it here and I punch in, it gives me 69168 joules. 69168 joules. So I get here 69, okay, 69168 joules. 168 joules. 168 joules. So that's our energy consumed. Now energy is the same as work done because they have the same what? They have the same units. Okay. They have the same units.
Hello.
They have the same
yes, question
units.
10, November 2023. Let's check it here. They say two smaller spheres, A and B, made of pure zinc are at rest 0.1 meters apart on a wooden table. Sphere A is negatively charged and is free to move on the table, while sphere B is uncharged and fixed to the table as shown in the diagram below. You can see it here. Sphere A is charged, sphere B is uncharged, it's neutral and it is fixed, but sphere A can move to the table. Okay, then they say high intensity UV light of frequency 2,8 exponent 16 Hz is now shown continuously onto sphere B. The wake function of zinc is 6,63 exponent negative 19 joules. They say define the term wake function of a metal. Now, what is wake function of a metal? What is wake function of a metal? Now, remember your theory, we said that wake function, let's 10.1.1. Wake function is what? Wake function, okay, 10.1.1. Now, wake function is the minimum energy, okay, wake function is the minimum energy, is the minimum energy required, is the minimum energy required to eject photoelectrons from the metal surface. Minimum energy required to eject photoelectrons from the metal surface. Required to what? To eject photoelectrons from the metal surface. Photoelectrons from the metal surface. From the metal surface. Okay. Now they say here that explain using a suitable calculation why the UV light shown on sphere B will eject electrons from its surface. Explain using a suitable calculation why the UV light shown on sphere B will eject electrons from its surface. Okay. Now let us look at our theory again here. We know that in photoelectric effect, okay, the incoming electrons have got energy, okay. The incoming light has got energy, so note that our equation says here that the incoming energy E, okay, equals to wake function plus what? Plus EK. This is EK maximum, okay, EK maximum. Now let us find out this E, the energy E given by HF, and compare it with our wake function, okay. All right, now they gave us the wake function. Now if our energy E is greater than this wake function, then you're going to have the remainder one to be used as kinetic energy, and hence you're going to eject photoelectrons. So because we have the work function given here as 6,63 exponent negative 19 joules, okay, that's our work function which we have. Let us get the energy E, because we have the frequency given to us as what? As 2,8 exponent 16 Hz. So our energy for the incident or incoming light, okay, is going to be E given by h times frequency. Now this h is a constant, which is Planck's constant, 6 comma what? That is 6 comma, let's check it here. That is 6 comma what here? If you check here, it is 6,63 exponent negative 34. 6,63 exponent negative 34. 60,63, okay, exponent negative 34, okay. Then times the frequency given to us, which is here. That is 2,8 times 10 power 16 Hz. That is 2,8 times 10 to the power 16 Hz. Okay. Okay, so now what's our answer here? Calculators, what do you get? If I check here with me my calculation, here it gives me if I multiply, I get 1,856 times 10 power negative 17. 1,856 times 10 the power negative 17 joules, negative 17 joules, negative 17 joules. Okay, now this energy E, if you look at and compare it with our work function, which was given as what? As this is 6,63 times 10 power negative 19 joules. Okay, what do we observe? That our energy E is greater than what? Than work function. You see this value is bigger than this one here. So for that case, that's why we are going to what? To eject photoelectrons. So therefore, we are going to eject what? We will eject photoelectrons. We will eject photoelectrons. We reject photoelectrons. Why? Because our energy E is greater than what? Than work function. Okay. Next question here. Let's check it out what they want here. They say that sphere A carries a charge of negative 5,4 exponent negative coulombs and requires a minimum force of 0,027 joules to move from rest. Calculate the minimum number of photons of ultraviolet light that must strike the sphere B, which will cause sphere A to move from its rest position. I repeat, they say sphere A carries a charge of negative 5,4 exponent negative 6 coulombs and requires a minimum force of what? 0,027 newtons to move from rest. Calculate the minimum number of photons of UV light that must strike a sphere B, which will cause sphere A to move from its rest position. Now, they gave us the force. Now, note something that the number of photons is exactly equal to the number of electrons. So, if I can get the number of electrons after getting the charge on sphere B, that would be the answer. Okay, so in this case, from Coulomb's law, what do I know? I know that the force, okay, is given by what? By K times charge on sphere A times charge on sphere B divided by the distance squared. Okay. Now the force given to me here, it is 0,027, 0,027. Okay. Now K is a constant, which is 9 times what? Times 10 power 9. Now the charge on sphere A is this one here, that is 5,4. Okay, 5,4 times 10 the power negative 6. Okay. Now I want to find out the charge on sphere B. Okay. Then later get my electrons, and that will be the answer. So distance is 0,1, as you can see on the diagram here, 0,1 meters squared. Okay, so in this case I'm going to get my charge on B, okay, given by 0,027, 0.27 multiplied by 0.1 squared, okay, divided by my numerator, which in this case is 9 times 10 power 9, okay, that is 9 times 10 power 9, that's 9 times 10 the power 9, multiplied by 5,4, okay, 5,4 times 10 the power negative 6. So my calculator here gives me what? Let me check it out. It gives me 5,56. I get 5, okay, 56 times 10 to the power of negative 9. Now, like I said before, that the number of photons is the same as the number of electrons. So now that I have the charge, let me find out the number of electrons. So I'm going to say that the number of electrons equals to what? Equals to the charge on sphere B divided by electronic charge. So I'm going to say 5, okay, 56 times 10 to the power negative 9, okay, divided by 1,6 times 10 power negative 19. So calculators, what do you get that side? Now here I'm getting 3,47 times 10 power 10 electrons. I'm getting 3,47 10 to the power 10 electrons. The power 10 electrons. Okay, that's my answer for those photons which are required for the sphere A to move from rest. Okay, next question here. They say here that a beam of white light is shown through a cold gas. The emerging light is dispersed in a line spectrum is observed on a screen. Okay, and then they say here that name the type of line spectrum observed. I repeat, the question says here that a beam of light is shown through a cold gas. The emerging light is dispersed and a line spectrum is observed. Okay. Now, when the gas is shown through the cold gas, when the white light is shown through the cold gas, okay, are we together? Now, this cold gas is going to absorb some of the light from there, and so the type of line spectrum is going to be called what? Absorption, because the gas is going to absorb. Okay, so you're going to see an absorption spectrum. So this type of called what? It's called absorption. Okay, it's called absorption. Why? Because the cold gas will absorb. So this is absorption. Then they say describe the spectrum referred to in this question. Now, because we had white light, okay, and though it is passing through the cold gas, it's going to be continuous, okay, but we're going now where we have absorbed those lines, it's going to be left as dark lines. Where we have absorbed those colors, will be left as what? As darker lines. And so for that matter, if they say describe the spectrum referred to, we're going to say it is a continuous spectrum of white light, but with darker lines. Okay, so it's going to be a continuous spectrum. Okay, it's going to be a continuous spectrum of white light, okay, but with darker what? With darker lines, because that's what was observed. With dark lines, dark lines. Okay. Now they say here the diagram below indicates some possible energy transitions made by atoms. Which one of the diagrams could result in the type of spectrum observed in question 10.2.1? choose from diagram A or diagram B. Now in this case, diagram A, we see we are falling from E1 to E0, E3 to E3 to E0. Now in diagram A, this is emission because we are decreasing the energy. Now in diagram B, because getting from ground state to E1 and ground state to E3, now this must be the answer where we are absorbing. So the answer is what? Is diagram B. The answer is diagram B, because if you get from ground state to E1 or to E3, it means you're absorbing energy. Energy is increasing, energy is being absorbed. That's why that energy left the dark lines. Now this question here, I want to explain it again. You don't have to call me. Now they say here that a simplified DC diagram of electric motor is shown below. They say here that in which direction will the coil rotate? Choose from clockwise or anti-clockwise. Okay. Now remember that the motor and the generator, yeah, they use different principles. Now with the generator, we use what we call as the right-hand rule. Then with the electric motor, we use what we call as what? The left-hand rule. Left-hand rule. Now this is what we do. Now first of all, this is the positive, where we have our electricity passing like this, then coming this way, then going up, okay, going up like this, and going up the coil here, then coming back like this, okay, and then going this way like this, and then like this, okay. So now according to the left hand rule, if you put the thumb, second finger, and then the first finger into at 90 degrees, now remember that in this particular case, our first finger must be in the direction north to south, and so I draw the arrow from north to south, okay, like this, north to what? To south. Now that's where it must be facing, okay. And then if you put the thumb at 90 degrees with this direction of north to south, now check here, the current in the coil is flowing like this, okay, coming like this. Now this is 90 degrees here, okay, 90 degrees here. And then now if you surely rotate your left hand, you're going to observe that if you want the current to face this way, and then the one for the field to face like this, okay, then as you rotate your fingers, you find out that this other one for the rotation of the coil is going to be facing down like this, okay, be facing down like this. And because this is the thumb now facing down like this, now it shows us that if I draw the line of axis like this for the coil, because we are facing down, it's going to rotate clockwise. So the answer is what? It must be clockwise. It's non-anti-clockwise. I beg your pardon, okay? It's gonna be what? Clockwise direction. All right. Thank you so much for watching. See you in our next video. This is Patrick Kamala, a tutor and educator here at College Pulkwani. Yes, you can reach us on 0785 222 041. Bye bye.